This video will examine example circuit number 4, which looks at controlling multiple LEDs, in this case 8, using 8 different outputs from the Arduino circuit board. So our schematic for this is going to be remarkably similar to every other time we've done a blinking LED. Our LED is going to be attached to an output, connected in series to a current limiting resistor, and then it's going to be connected all the way back over to ground. And we're just going to do this for every single one of these LEDs. So now this isn't the most exciting or original of circuits. It is merely an extension of everything that's been done up to this point, out to just using a whole bunch of different LEDs. And mainly it's going to look at how you control those LEDs with respect to each other rather than anything sort of fancy with them. So it's going to look at having your signal do various things, like make the LEDs blink in a certain sequence rather than anything else. And running out of room, so go around the back side, connect to here, connect to there, junction there. So while there's rather more wire crossing than I really like included on any schematic like this, the gist of it is that each of these LEDs is individually wired to one data output from the Arduino, and each output is going to have dedicated control over that LED. So we've just got a line of LEDs hooked up, each like they were one individual LED we're going to be blinking. So the sketch for this is the multiple LEDs sketch, and the first thing they do is define as a global variable LED pins as an array. So an array is a set of variables that all share the same type, that are stored under a single name and referenced by their index. So this is an array of size 1, 2, 3, 4, 5, 6, 7, 8, because it contains 8 elements. It's an integer array, so it contains 8 integers, and the index of these various elements is going to be 0 for the first one, going through 7 for the last one. So the indexes start at 0 and go up to the size of the array minus 1. So that's the important bit to remember about arrays. The first index is not 1, it is 0. So lead pins of 0 is 2. If you try and put in lead pins of 1, you'll get 3. And if you try and put in lead pins of 8, because this is a size 8 array, either it will return an error message because you have put a value that is beyond the size of this array, and it's smart enough to check for that, know the size of the array, and tell you you've done something you're not supposed to do, or it's going to go look at what would be the value at size 8 for that array, but is unallocated memory, or is memory for something else, and it's basically going to pull random noise off your computer board and put it in for that value. So nothing could happen, or something very, very unexpected could happen. Either way, keep your indexes within the size of the array. So for the setup, they first define a variable index, and then they write a for loop where index starts at 0, goes to 7, and increments 1 each time, and then turn on all the pins that we're going to be using for this. So pin mode is led pins of index. So index is starting at 0, so if we go back to led pins of 0 is 2. So the first time the for loop goes through, it's going to turn on pin 2 for output, and then it will continue down this array until index is 7. The loop will terminate, which will also be the end of the array, and it will turn on all 8 digital pins for output. So here in the main body of the program, they've written a number of functions which it would call to do various things, and each of these functions are going to control the LEDs in a different way, but currently the program will only run one of these functions repeatedly, as the other functions have all been commented out. So it's still included as part of the program, but the program doesn't read it and see it as something to do. So the first one is entitled One After Another No Loop, and the comment says that that's going to light up all the LEDs in turn. So void one after another no loop first defines a delay time, and then it turns all the LEDs on in sequence, writing each individual line of code to do so. So digital write led pins of 0, so 2 in this case, high, turn it on. Wait, next pin, wait, next pin, wait, so on and so forth. And then the same thing in reverse, every single line of code written, starting with led pins of 7, so pin 9, wait, pin 8, wait. So this is going to turn all the LEDs on from one end of the line to the other end of the line, and then off from the other end of the line back to the start of the line, and it's going to do so writing every single line of code required to do so. This is perhaps the most inefficient way to do this, and it will work, but you are massively bloating your code, and you really do not want to do this if you've got any other way to do so. So the next function, after one after another no loop, is one after another loop. So void one after another loop. It starts by defining index and defining a delay time, and then it writes a for loop that says for index starts at 0 and goes to 7 and increases by 1 each time, turn on each of the pins in order as index goes from 0 to 7. So starting 2, 3, 4, 5, 6, 7, 8, and then finally pin 9, waiting for your delay time between each time you turn them on. So that should turn all of the LEDs on from one side of the line to the other. And then to turn them all off, they write another for loop where an index starts at 7, goes to 0, and decreases by 1 each time. So digital write led pin of index should start at the far end of the line, come back to the start, and this digital write low will turn them off just one at a time. So it should do exactly what the previous thing did, but the coding is much more compact. The next code, or the next function written in, is one at a time, and the comments say that it's going to turn on each LED one at a time scrolling down the line. So let's go find one at a time. So void one at a time. It first defines an index and a delay time, and then it says for index starts at 0 and goes to 7, increasing by 1 each time, turn on the LED that matches index, so starting at the first, going to the end of the line, wait, and then turn it off before repeating the loop. So one should turn on, wait, turn off, the next one should turn on, wait, turn off, and so on and so forth, just down the line. So you should have one single LED line, or one single LED that appears to travel lit down the line from one side to the other, and only from one side to the other. When it reaches the end, it's going to go back to the start and travel down the line again. The next one written is ping pong, where it's going to light the LEDs from the middle to the edges. So if we go down to void ping pong, it first defines an index and a delay time like every other function, and because all of these functions are separate entities, they do each need to say, I need an index and a delay time. If these had been created in a main function, you could theoretically pass those values into any of these functions if they had a receive values, like say int delay time. So you could have void ping pong int delay time and pass it this delay time, and you could also pass that delay time to all those other ones. But for this case, they're just writing them as if they're entirely separate entities that are just called by the main program. So for this one, they start at 0, going to 7, increasing by 1 each time, turn the LED on, wait, turn it off again. So that's going to go from one side of the line to the other, just like the previous program, but they've got a second for loop that starts at 7, goes back to 0, decreasing by 1 each time, and it's going to turn that one on, wait, and then turn it off. So this program should light the first LED, travel to the end of the line, light the last LED, light the last one a second time, travel back to the start of the line, and light the first one, and then repeat again. So the light should appear to travel from one end to the other, doing a double blink at both ends. The next function is marquee, which states it should have chase lights like you see on signs. So in this case, where the previous one at a time and ping pong had one single light that appeared to be moving, marquee is going to have a pair of lights that appear to be moving. So marquee defines index and defines its delay time, and it's going to light up the LEDs from 1 to 4 and 5 to 8 in that order. So in this case, index starts at 0 and goes to 3, increasing by 1 each time. So the first thing the program does is light the LED at position 0, so the one associated with pin 2, and then it also tells it to light the one at index plus 4. So in this case, it's going to be 0 plus 4, so turn on the LED associated with the 4th number in the LED pins matrix, which would be 2, 3, 4, 5. So the one associated with pin 6. Yeah, the one associated with pin 6. So it's going to turn on the ones associated with pin 2 and 6, or the first LED in the line and the 4th LED in the line. Then it's going to wait, and then it's going to turn them off. And then when the loop repeats, it's going to turn on the 2nd and 5th LED in the line, or sorry, the 2nd and 6th. The first loop should be turning on the 1st and 5th. This one will turn on the 2nd and 6th, turn them off, then the 3rd and 7th, and then the 4th and 8th. And then it's going to loop back to the start, and because it's looping back to the start, where it's going to turn on the 1st and 4th again, it's going to look like that middle one passed from the 4th to the 5th, or yeah, the first one's going to turn on the 1st and the 5th. So it's going to look like it passed from the 4th to the 5th, and the one on the 8th is going to appear to have looped back over to 1. And finally, the last one associated with it is random LED. where they're going to use a random number function to determine which LED they turn on at any given time. So void random defines index and delay time, and it says index is going to be random of 8. So random calls a random number between 0 and 1 minus the parameter you give to random. So 8, it's going to give you a number between 0 and 7. It then defines the delay time as 100, and it says turn on that random pin I just called, or the pin associated with that random number I just created, wait, and then turn it off. So this function's only going to turn on one LED and then kick it back to the main function, which is immediately going to loop and recall random, at which point it's going to call a new random number and do it again. However, since this is a computer random number generator and not a true random number generator, since I'm not changing the seed in between each time I start up this program, if I start up random LED, it should give me the same numbers in the same order every time I restart that program. So if it started with, say, LED 2 and then went 5, 7, 9, if I reset the program and told it to go again, it should do 2, 5, 7, 9 again, and would do so each time I called that program. In order to make it have a different value each time, you have to reset the random number seed every time you call this program. And there's a few different ways to do that, but we're not going to go into them in this video since we're already getting towards the end and I haven't even shown you the circuit yet. Or we're already past 15 minutes and I haven't even shown you the circuit yet. So, starting with one after another no loop, which is very, very inefficient, but should light them all in a line and then delight them back down that line. So let's switch over to the camera. You've got our line of LEDs. Let's upload the program. Lights them up in a line, brings them back down the line. So, nice and simple. Does what it's supposed to do. Now, if I comment out one after another no loop and decomment one after another with a loop, it's still running the previous program, but if I upload this program again, stops interrupted, and it's going to appear to do the same thing because this function is designed to do the same thing, it's just written far more efficiently. So let's go over to some of the ones that should actually have a different output display. So one at a time. This one should give the appearance of a single light traveling down the line, and when it reaches the end, it should go back to the start, do it again. So still running the previous program, let's upload one at a time. And yep, you've got a single light traveling down the line, and when it reaches the end, it goes back to the start, does it again. So, next one on the list is ping pong. This one, instead of going back to the start, should stop at the end of the line, blink an additional time, and then head back down the line. So we've got our LEDs, upload the program, and yeah, it's holding on those end positions for slightly longer, but yeah, it's bouncing from one end to the other, and the blink that would occur at the end, in between when it goes from one to the other, the delay is simply so small that you'll never notice it. It turns off for microseconds, whatever your computer's processing clock is. So it just appears to bounce from one side to the other, sort of pausing a little bit, just a little bit at the ends. So next is marquee, where this one should appear to have a pair of lights that follow each other or chase each other down the line. So let's upload the program, and there we go. You've got a pair of lights, 1 and 5, 2 and 6, 3 and 7, 4 and 8. And the loop goes through those, so the loop is half the size that it appears to be because it's turning on and controlling two things at once. So the loop actually exists as a light travels from the first to the fourth, and then the program resets itself and does first to fourth again, because at the same time it's also doing 5 through 8. And now the last one, the random number one. So we're going to comment out marquee, and we're going to pull up random. So upload random. And yeah, that's dancing pretty fast, but I'm pretty sure it started with number 8. So if I upload this again, yeah, 823, and then it just starts doing various other things I can't notice. But yeah, it's randomly jumping between various ones, and every so often it appears to pause, so that means it's got the same number twice. But I uploaded it again for a third time, 823, yeah. So it's random, but only random in that it's choosing from a list of randoms. The random list is the same every time I run this program. So that's all various different ways that you can control sort of the output of a set of LEDs as opposed to just a single LED. So you can look at these things and you can start moving on to more complicated displays that show things like numbers or letters or other things. You can give patterns and other things. This is an extension of the sort of I'm controlling 3 LEDs that we showed with the RGB LED.